I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, September 5th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the South Pacific Ocean, we see a gale with 36-foot seas in the central South Pacific, aimed reasonably well to the northeast, generating swell that is radiating towards our coast. And there is swell actually hitting as we speak. Let's get into the details. Looking at the buoys, Barber's Point in Hawaii, you see a small bump here of energy, very small. What is that, like half a foot in the 15 to 14 second range? But accumulated energy, scrolling down here if we can get down to the bottom, you see swell of, a foot and a half or so at 14 seconds primary swell. And this swell was actually a bit bigger yesterday and the day before. I mean, there were head-high sets at top spots and pretty lined up and pretty good. That swell is radiating towards California and starting to hit as we speak. A quick look at the southernmost California buoy, Point Loma South in California. You see energy in the 18 to 16 second, probably right about 18 seconds really building. See heights, and actual swell size of 1.8, 1.6 at 17 seconds, something like that, pushing up from the southwest. And so there is very minor swell hitting, expect a little bit more expected as we get into Monday. Nothing huge, but at least rideable surf is on the way. So looking forward, we're looking at jet streams level winds in the southern hemisphere. This is the northern branch here. This is the southern branch. We're looking for a trough that would help form a gale or support gale formation. So we're looking for the winds in the southern branch of the jet to push north, just like they are right here. Now, not a lot north, and not very strong. It's only 110 knot winds in that area, but that helps create a clockwise flow aloft and down at the ocean surface. That is the hallmark of low pressure. Of course, low pressure, if it's deep enough, generates winds on the ocean surface. Those winds, in turn, if they're strong enough, generate seas. Those seas, if they're high enough as they radiate away from the fetch area, turn into swell. And swell, if it's long enough and has enough period, when hit your beach, turns into surf. All right, and we know there is small swell hitting California now. This is the next opportunity for swell production relative to Hawaii and California. As we look at the jet as we get deeper into Sunday, that trough builds a little bit more. Wind energy builds over the far southwest Pacific, and the trough sweeps off to the east as we get Monday into Tuesday with 150 knot winds, maybe even a little bit more. That should help support gale formation, and maybe a little secondary pulse as we get later into Tuesday. The cutoff for Southern California is about 118 west, so right there. So maybe into Tuesday afternoon. Now the trough there looks really good as we get into Wednesday, but it's east of the California swell window. So great for South America, Peru, that area, Central America. Not so great for California. Behind that, big ridge sets up, pushes down south. The Arctic ice line's about 62 south, something like that. So no real clear support for gale formation. There's not even any wind energy pushing to the north in this blank space back here under New Zealand. So we're into Thursday, really nothing. And the ridge, the opposite of a trough, winds pushing to the south, not supporting gale formation, pretty much continues on. Ridge building stronger as we get into Saturday night and Sunday, and we're a week out, and clearly no obvious support for gale formation. So whatever's happening now is going to be it for at least a week. Let's go take a look down at the surface. Here we are, surface level winds, surface level pressure. Clearly a good solid, 944 millibar low in the deep South Pacific with 45 knot winds pushing well off to the northeast. This is exactly what you want to see to support gale formation. The winds actually, as we get into Sunday, right about now actually, almost pushing more to the north and then the gale fades a little bit as we get into Monday, but still good solid fetch of 40 knot southwest winds. New gale developing behind that, getting traction. That's almost 50 knot winds over a small area on Monday night into Tuesday, building tiny area of 55 knot winds, and then solid area of 50 knot winds midday Tuesday, and then 55, 60 knot winds on the edge of the California swell window Tuesday night, and then pushing out of the swell window, and it's all gone after that. So 70, we'll say 80 hours or so from now, all swell production ceases relative to California, Hawaii, and the South Pacific. And another low sets up, but high pressure here driving all the winds south towards Antarctica, nothing towards the U.S. West Coast or Hawaii. We're into Friday, Saturday, more of the same. All the arrows pushing southeast, doing nothing. We're into Saturday. Another big low developing south of New Zealand as we get into Saturday night and Sunday. But again, the fetch here, the strongest fetch, 40 knot winds, all aimed south, tiny area, 35 knot winds. That's not going to get enough traction to really do anything. And so that's it for now. All right, let's go look at the effect of those winds on the ocean surface. Now we're going back a week ago because a small gale formed. It wasn't big, 29-foot seas. It actually formed south of New Zealand. I think it was on Saturday or maybe even Friday. And then last Sunday it pushed into the southeast Pacific with 29 to barely 30 30-foot seas, and then out of the swell window. That is the system that made the tiny, and I put that in quotes, tiny swell that hit Hawaii. Again, Hawaii had high sets, which isn't bad. We're not expecting that into California, but something as we get into Monday and Tuesday, and maybe dribbles into Wednesday and even Thursday. But again, small, very low expectations for the swell. Don't get your hopes up. And then we went through the whole of last week, and really, we're looking for anything. There's 32-foot seas, but they pretty much were just way to the south. Finally, on Friday, this is 2 days ago, something started building south of New Zealand. This is the system we're interested in. 36.6-foot seas developed on midday Friday. Continuing east, that got some traction, maybe generating some swell. Pushed off and into Saturday. A secondary fetch started building Saturday night, and then here's where we are as of right now with 37.3-foot seas. Let's go look at the models now looking forward. All right, and into this evening, up to 39-foot seas projected by the GFS wave model, and continuing into Sunday evening, lifting pretty well off to the northeast, continually plodding east into Monday. Secondary fetch building over the south central Pacific on Tuesday. That builds and blows up a little bit. Remember, 50, 55 plus knot winds in this area. 43.4-foot seas forecast as we get into Tuesday evening, and continuing in that range before, well, there's the cutoff right about there. So Wednesday morning, we have 39-foot seas aimed pretty well to the northeast, still in California and Southern California swell window. And then out of the picture, sure, seas here aimed towards Mexico, Central America, Peru, Chile, but not at California. And then this little fetch area builds supposedly Thursday, Friday, but all the fetches aim to the southeast, and that's pretty much the picture. We'll just roll through here, and you see, that's the end of it. So this next run, which really consists of so we have the small swell now, and then about a week from now, a 3-part swell, 3 different fetch areas, sort of a small building one in the west, another in the southeast, and then a stronger one in the far southeast Pacific. So, maybe a good week of swell is possible, assuming all this plays out expected. But it's not like we're looking a week out. We're looking 72 hours out. The models have been quite stable, so it seems reasonable that all this is going to happen. A quick look up at the North Pacific. All is pretty quiet at the moment, but little gale forecast here on Monday through the Gulf. Not supposed to do much. What's that, like 12-foot seas or something? A stronger one, though, is forecast behind that. Here we go, pushing over the date line. Nothing huge. Wednesday, Thursday, building 18, 20, 22, 23-foot seas, building to, what is that, probably 26-foot seas. Notice a tropical system here and here, but that's 108 hours out. We don't believe any of that. So this is going to be the main focus. If this happens, 26-foot seas, that's good for maybe 15-second period swell pushing into the, well, actually, let's sort of go back. So right there. So probably nothing for Hawaii, or minimal energy for Hawaii, more for the Pacific Northwest, and maybe some energy down as far south as Point Conception. Size probably pretty minimal, but that would be a next weekend type event. So that would actually be in sync with Southern Hemi swell. So interesting indeed. There is some potential, but then after that, it's over. We'll see. This seems a little bit overhyped anyway. We're not betting on it. The Southern Hemi is much more of a sure thing. And then the potential for wind swell, well, looking at the situation, high pressure, pretty weak, 10, 22 millibar high. It's that time of year. Once you get into September, the Gulf of Alaska high, the North Pacific high really starts fading out, losing some energy. Low pressure typically starts building. The potential for wind swell development starts dropping off. And as you can see on Sunday, no real fetch along the California coast. 10 knot, maybe a couple little pockets of 15 knot winds. East trade winds, 15 knots into Hawaii. So maybe some wind swell on east facing shores. But then here's the first little low on Monday. And when you see a low there in the Gulf, the odds of there being some larger high pressure system pretty much drop off. Yeah, there is some pockets of 15 knot winds Monday along the California coast, but not generating any wind swell. And this low itself quickly fades out, doesn't do anything. Pretty slack pattern Tuesday. Wednesday, oh, here, another little low. This is new on the charts. Just off the coast of Vancouver Island, not doing anything. 15 knot winds along the California coast. Maybe some 6-second period wind chop or something. But that here comes the broader low on Thursday with 40 knot winds, maybe 45 knots. That's actually pretty solid. But again, 102 hours out, I'm not believing it. Wind swell, yes, some 20 knot winds Thursday night along North California. Maybe some junky wind swell for California. The low looking still pretty impressive as we get into Monday. Into Friday. Wind swell for California. Yep, more wind swell. Another low trying to push into the Gulf as we get into Saturday next weekend. High pressure getting a firmer grip. Here comes northwest winds. That will probably trash whatever swell is intermixed with it, unless you got a very good, well-protected break, assuming the models are right. And then into Sunday night, more of the wind swell for California. But, nothing too much to get excited about. Certainly no chance of snow up in the Sierra. We would certainly like to see it, or rain or anything. Snow levels above 14,000 feet pretty much the entire 10-day window. So no sign of some impending cool down or something that would smell of fall in the Sierra just yet. So that covers it for the next week or so. Let's go look out much longer. What's going on with the Madden-Julian oscillation? That can give us a good view, maybe a month or 2 or 3 out. And the El Nino Southern Oscillation, that'll give us go out maybe 6 months, 7 months or beyond. And hopefully looking for a better pattern. So as usual, we start off looking for any signs of the active phase of the MJO, the Madden-Julian oscillation. It is this periodic weather oscillation. It has 2 phases, an active and an inactive phase. The active phase rotates on half the planet. The inactive phase on the other side, they rotate around the planet on the equator, moving from west to east. So if you have the active phase in the Pacific, the inactive phase is on the other side of the planet, and then vice versa as they rotate around. The active phase takes about 5 weeks to make it from the West Pacific over here. That's the West Pacific, New Guinea there, on the equator, moving across into the East Pacific and eventually into Central America. All right, so this is data from the TAO buoy array, series of buoys strung off the equator used for monitoring El Nino, but they have wind sensors on them too. So you can look for clues of the MJO. The active phase is what we want. The active phase of the MJO is effectively low pressure, and that low pressure lifts air up. It helps create a cloud cover, storms, imparts energy to the jet stream, which then, if the jet stream is strong, both in the north and southern hemisphere, it then feeds storm production. Of course, storm production makes swell and surf. Likewise, when the inactive phase is over the Pacific, it's acts like a high pressure system, sinking air, steals energy from the jet stream, doesn't feed storm production, and it's dry air. All right, so what we're looking for here is winds, 5-day average winds. The longer the arrows, the stronger the winds. So pretty strong winds out of the east over the East Pacific. Same thing over the Central Pacific, and pretty much the same thing over the West Pacific, the Kelvin wave generation area. That is, when the active phase of the MJO is over the West Pacific, it can reverse the trade winds, and that in turn can take warm water that's here, start pushing it off to the east, and that warm water pool is what they call a Kelvin wave. So, and Kelvin wave production happens here in the West Pacific, so we call that the Kelvin wave generation area. All right, but it's not actual winds that matter. It's the anomalies, differences from normal for this time of the year. So again, we look at the arrows and go, yeah, up here, winds are pretty strong out of the east, but you look at the arrows and go, well, compared to normal, I'm not seeing any particularly east or west direction, so that's pretty much neutral. Get over the Central Pacific, well, I'm seeing easterly arrows, so maybe the trades are a bit stronger than normal here. And in the Kelvin wave generation area, trades certainly are stronger than normal here out of the east. Okay, the active phase of the MJO actually stomps on the trade winds, suppresses them, and helps them reverse direction, so we're not seeing any sign of that. So this suggests the inactive phase of the MJO is in control, and of course the inactive phase does not really support storm production. We say that, but we looked at all the models, and we clearly see a storm in play and another system getting ready to form in the South Pacific. So it is not a one-to-one correlation, and really the South Pacific association between the active phase in the MJO and storm production is a lot looser than in the northern hemisphere in the winter. In the northern hemisphere in the winter, when you have the active phase of the MJO in the West Pacific, you're pretty much guaranteed some increase in storm production and therefore swell production. All right, let's go take a look off in the future. So this is the 7-day forecast for trade winds on the equator, 5 degrees north and south of the equator. There you go. Okay, zonal wind anomalies. Fancy words for is the wind blowing stronger out of the east compared to normal or stronger out of the west? Okay, now notice the date is September 2nd, so this is 3-day-old data. I'm sure that come Monday or Tuesday when everyone gets back to work, they'll resolve this. But we can use this to get a rough idea of what's going on. Right, whole planet on one chart, but all we care about really is the West Pacific. West Pacific starts at 135 east, so right up that line there. And the Kelvin wave generation area ends at 170 west, so right about there. This is the area right here that when you have west anomalies, the active phase of the MJO in the West Pacific, it supports storm formation. But the blues are easterly anomalies, stronger than normal trades. So that's a sign of the inactive phase of the MJO. So for the next week, this chart suggests a building inactive phase of the MJO. And I think this is GFS model wind data too. I'm pretty... There it says it, GFS. Okay, so that's a pretty good model, not some sort of statistical weird model. This is a dynamic model, so that's probably exactly what's going to happen. So let's go look 2 weeks out, okay? Outgoing long wave radiation, fancy words for sunlight reflectivity off the ocean surface. So let's think about this a minute. The active phase of the MJO is like low pressure, and low pressure creates clouds. So if you have a bunch of clouds, you're not going to get a lot of sunlight reflectivity off the ocean surface. Likewise, if you have high pressure typically is cloud-free skies. You get a lot of sunlight bouncing off the ocean surface. All right? So the color scale here is positive. The oranges and reds is a lot of reflectivity off the ocean surface. So one can infer that. Oh, and let's get oriented. The equator right there. South America, Central America, Hawaii, New Guinea, Australia. Kelvin wave generation area from 135 east, right there. 5 degrees north and south of the equator to about right there. So draw a box in your mind's eye right there. And there's a panel for 5 days from now, 10 days from now, 15 days from now. So a neutral MJO pattern forecast right now. 5 days from now, inactive phase, more sunlight reflectivity off the ocean surface, with the active phase over in the Indian Ocean there. And pretty much inactive phase building for the next 2 weeks, 15 days. Per this model, this is a statistic model. Now the dynamic model paints not nearly as gloomy a picture, suggesting pretty much a neutral to weekly inactive phase of the MJO for the next 10 days. And then the active phase starts making its move from the Indian Ocean over the maritime continent, like Bali in that area right in here, and into the Pacific. So, of course, this is the preferred outcome. But the two models, let's see if we can get them both in here at the same time. A little bit tight, well, that's strong inactive phase, that's building active phase. A little bit of a disconnect between the two models. And then these charts, phase diagram charts, really show the level of the disconnect here. All right, so what are we doing? What are we looking at here? Well, we know the MJO moves from west to east, from the Indian Ocean, over the maritime continent, over the West Pacific, over the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. Probably North Africa is more like down here. All right, where the heavy dot is, and where is it? It's roughly right in there. That's where the active phase is. So in the Indian Ocean, and we saw that on the other charts, that's about right. The further the dot is away from the circle, the stronger it is. So if it were out here, very strong active phase. But this looks like a very weak active phase in the Indian Ocean. According to this, the statistic model, the active phase over the next 15 days is to make it to roughly the maritime continent, but exceedingly weak. Now, the GEFS model, GFS ensemble model, says, well, some variation of the same, but the active phase, look at this, bump, 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 building to moderate to almost strong status over the maritime continent 15 days from now. And it's even interesting, you look at some of these just stray members out here pushing it even stronger, moving towards the West Pacific beyond, we'll say, 2 weeks from now. So a big disconnect between the two models. Clearly, this is what we want to see. We're not expecting it. In reality, it'll probably be somewhere in between the two. The 40-day model, this is a statistic model, so it's going to favor the inactive phase. I can already tell you that. Right, what are we looking at here? Well, there's 8 different panels, 5 days per panel. South America, Central America, equator is 0. Okay, New Guinea there, so the date line's roughly somewhere in this area. The Philippines, Kelvin wave generation area right here. So this is potential for precipitation. Yellows and oranges, dry air, inactive phase of the MJO. Greens, wet air, active phase of the MJO. So this model predicts the inactive phase pushing over Central America. Well, actually, Ecuador. This is the equator right here. Oh, we'll say about mid-September, September 15th. And even before then, by the 10th of September, some sort of active phase building into the Pacific, across the Pacific, the whole way through into about, we'll say the 10th of October. So mid to late September through early part of October looks like a window potentially for active phase of the MJO, therefore fueling the jet stream, therefore fueling storm development. And then after that, another inactive phase as we get into the October-ish time frame. It's really interesting to see how these models sort of contradict one another. So then we look at this, the CFS model, which is a dynamic model. Whole planet on one chart again. Date line runs right up the middle here. Far West Pacific, about 135 east, so right in there. Kelvin wave generation area right in that pocket there. This is past performance. The solid contour is the active phase of the MJO. This is one that happened back in July, we'll say, into the early first part of August. With the oranges are westerly anomalies, right? Okay, and then you see after that, there's no inactive phase of the MJO, but you see this building the blue, the easterly anomalies, synonymous with the inactive phase of the MJO. Then you look at the forecast and you see continued easterly anomalies with no westerly anomalies pushing into the Kelvin wave generation area through October, where the last model we saw said something about, well, maybe in mid-September we could see something that looks like an active phase of the MJO. So a bit of a disconnect here. Let's keep digging. All right, and then the CFS model going out 3 months. So this is a little bit different. This is past performance down here. This is future up here. Where are we? Dateline runs right up the middle. Kelvin wave generation area starts about 135 east. So the box right in about here is what we're interested in. The blues are eastern anomalies. The blues are easterly anomalies. The yellows are westerly anomalies. The active phase of the MJO, the inactive phase of the MJO. So this model, just eyeballing it, says inactive phase, and you can literally see the transition moving into the West Pacific about October 7th and continuing the whole way through. And then after that, easterly anomalies. As you get into Halloween, easterly anomalies, and this would be synonymous with also with La Nina, pretty much fades out as we get into November, and you're left with this weak westerly wind anomaly pattern. That is, if you believe a model that goes out 3 months. Okay, we're eyeballing it. Let's overlay the MJO. Okay, so this is, okay, not too bad. The dotted contour is the inactive phase of the MJO. You see it moving out of the Kelvin wave generation area somewhere in mid to late September. And we kind of have this dead air in between. The solid contour, 1, 2, 3, 4, 5. Okay, pretty solid active phase of the MJO setting up in first week of October, maybe even earlier, maybe late September, and holding the whole way through in the Kelvin wave generation area till middle of November. After that, another inactive phase, but even then, westerly anomalies continue. All right, that looks pretty good. Also, we talked to Kyle McRitchie. He's the guy that runs this site. The question was, what do each of these little boxes here? We know that the fifth box is the mean of these guys, the sort of the sum of all of them, the average of them. So I asked him, well, what are these for? And we suspected this was the 0Z run of a model, the 6Z, the 12Z, the 18Z run. And the suspicion was that it's an accumulation of maybe a week of 0Zs, a week of 6Zs, etc., or maybe 10 days worth. He goes, no, it's way more simple than that. This is the most recent 0Z run, so like 0Z Sunday, 6Z Sunday, 18Z Sunday, 12Z Sunday, and then since the 18Z hasn't posted this would be the 18Z run on Saturday. So it's just the most recent 4 members of the CFS model. This is the CFS. It runs 4 times a day. And then, or we just average them all together, right? Okay, so let's go take a look at let's overlay the low pass filter here, right? Okay, so what is this? The solid contour is a low pressure bias. Think of that as the active phase of the MJO, or almost even El Nino. The dotted contour is a high pressure bias. Okay, that's like La Nina or the inactive phase of the MJO. So right now, nothing going on. But a high pressure bias is forecast to build over the date line in a couple of days and hold for the next foreseeable 3 months at least. A second contour line developing in October, but then quickly fading out. So this is what generally, when you talk about La Nina in the Pacific, this is the signature you'd see. So though these east anomalies, these blues here that we're seeing, are moving out of the picture, that doesn't mean the high pressure bias completely is gone. It's still there. Some sort of La Nina pattern still holding. But just for fun, let's do this. Let's look at the 0Z run of it. Okay, and now we'll go look at the 6Z run, a little bit weaker than the 0Z run. The 12Z run came along and it was a little bit stronger again. We're just seeing how each run of the model, there's subtle differences. The 18Z run Saturday, weaker again, but just sum them all together and this is what you get. And it's only a 24-hour sum, so that's as good as anything. We were just picking on the 18Z run misthinking about what it was, but from here on out, we'll just use the fifth one, and that's a good, reasonable representation of what's going on. So high pressure bias looks forecast for the next 3 months, some flavor of La Nina continuing. All right, so enough of the MJO discussion. Let's go talk about El Nino, La Nina. We're going to start by looking at ocean temperature depths down, subsurface temperatures. This is the West Pacific here, East Pacific here. We're going down 100, 200, 300 meters. It's really about 150 meters or up that matters, because that's where Kelvin waves are. They're down about 150 meters in the West Pacific, and then they travel from west to east, driven by westerly anomalies in the active phase of the MJO. It takes 3 months for the warm water that gets set in motion by the active phase of the MJO to move from the West Pacific to the East Pacific in the form of a Kelvin wave. We start by looking at the balance of water temperatures. This is centigrade temperatures, the 29-degree isotherm at about 175 east. I think that's where it was last week. The 28-degree isotherm, it was at 171 or 2 last week. Maybe lost a degree, but yeah, it's not too bad. And the 24-degree isotherm, I think it was at 120 west last week, backtracked to about 124 this week. Oh, also, these are the anchor lines. This is how the data is derived. Here's the anchor lines on the buoys. Notice, oh, and the X's are sensors on those anchor lines. Notice a bunch of the sensors, if they're not working, as they aren't right in this area. I mean, there's like probably something that's supposed to be anchored right here. Literally no data. No data near the surface here. So from, we'll say 165 west to 130 west, there's literally no data. That's a pretty big gap. There's a model that tries to fill in and make up the difference. So this model, now we're looking at anomalies. Differences from normal for this time of year says warm water in the West Pacific, bunch of sensors there, so that's probably about right. But then you get here, it shows warm water branching the whole way to the East Pacific, but there's literally no data here, so it's just making something up. And then you get real data here that says, okay, maybe 0 to 1 degree anomalies, so a bit of warm water there. But also cold water at depth in this area and off in here. Also, oh, there are sensors right along there, but there's probably some more somewhere. I think there's more density than this is showing. Anyway, cold water at depth, warm water at the surface. We're going to take that very much with a grain of salt, because there's another model we need to look at. This one right here, and my guess is this one also assimilates data from the next chart we're going to look at from satellites. So it's not just purely based on the sensors on the TAO buoy array. It pulls in other data and tries to get a more robust, a more well-balanced view of what's going at depth in the ocean. Again, West Pacific here, East Pacific here, down 150 meters. Yeah, lots of warm water building here in the West Pacific. But then you get to 160 west, brick wall, cold water filling from there off to just about Ecuador. This is a typical La Nina kind of signature, and we believe this is probably closer to the truth. And then you have this data. None of it's derived from sensors and buoys and all that. Pure satellite data. It is the Jason 3 satellite makes a bunch of polar orbiting satellite. It just goes around the circle and the Earth twists under it. And so it makes a swath every 90 minutes or something like that. And eventually it covers the entire planet of the surface of the Earth. I don't remember, maybe in a week or something like that. But the point being is, you take this data, you strip out the wave heights, significant wave heights, you strip out the tides, strip out the wind waves, strip out swell, and then you're just measuring the sphere of the ocean. Is it higher than normal or lower than normal? In this case, it's 10, almost 15 centimeters below normal. And here's the equator. Here's the date line. Kind of a weird stretched out chart. Chile, Peru, Central America. There's the Yucatan, Mexico, Baja, Hawaii right there. New Guinea, the Philippines, you get it. So you see this 15 centimeter divot here. Literally, so cold water at depth contracts, right? That'll create a little divot on the ocean surface. 15 centimeters. I don't know, what's that? Something like that. It's not very much, right? But the satellite can pick it up. That suggests cold water at depth. Now, especially if the trades are stronger than normal here, they're going to scoop water out here, start pushing it into the West Pacific where, no surprise, water is warmer. It expands. It creates a bump on the ocean surface. And then additionally, the trades pile water that's scooped out by the trades from here, deposit them here, and you get a bulge on the ocean surface. So if you take this and then map this into that previous model that's showing cold water in this area, well, this sort of says the same thing. From Ecuador over the Galapagos, almost out to the date line, colder than normal water at depth. And that, again, is the classic La Nina signal. You also see the warm water sort of doing this horseshoe pattern thing here. If you got the trades blowing from east to west here pretty strong, and then the warm water that builds up here tries to escape around the edges of this just steady easterly flow. And so again, sort of indicators of a classic La Nina. This isn't as strong as we've seen in the past, but still clearly a La Nina signal. Ocean surface temperatures up next. Sea surface temperature anomalies, differences from normal for this time of year. So we have, here we go. South America, Chile there, Peru, Ecuador right there, the equator right along there coming into Ecuador, Galapagos, there's little freckles right in there. Okay, Hawaii, Mexico, Central America, you get the idea. All right, so a little bit of warm water off of Ecuador, but once you hit the Galapagos, colder than normal water right along the equator. The thing that matters, believe it or not, only 5 degrees north and south of the equator, right on the equator, from here the whole way across the Pacific. The official El Nino monitoring region is from 120 west out to 170 west, so right about here, 5 degrees north and south of the equator. Clearly, just eyeballing it, the balance is towards colder water. But we also look here to get a sense of, where north of wherever warm water is where you get precipitation. Cold water does not, it supports high pressure, doesn't allow for evaporation, right? Okay, so this all sort of indicates a dry pattern for California as we get into the fall and maybe winter. Ignore this. This warm water here is right under the center of the North Pacific high pressure system. There's always dead air. You get a lot of heat warming, but it's what's on the equator that matters. But also, you see, as the center of high pressure is here, you get this this is building. I noticed this just in the past day. Building cold water flow along Cape Mendocino, North California, and off, you can see the warm water building up into Southern California, Central California, up to about Point Reyes. Then you get north of there, and the temperatures drop dramatically. So this is outflow from high pressure, stronger than normal high pressure driven by La Nina. Okay, you have cold upwelling along the equator driven by that stronger high, and a stronger high down in the southern hemisphere, again driven by La Nina, causing the trades to be enhanced here. And then you throw the inactive phase in on top of that, and it's just a recipe for more cooling and the continuation of La Nina. Now here's a little glimmer of hope. Sea surface temperature trend for the past 7 days. All right. The reds are warming temperatures. We only care what's going on in the equator, and there's a big warming pool here, at least for the moment, from Ecuador out to about 110 west. And cooling temperatures, not so impressive at all. Last week it was really cold in this area, so all this is saying is temperatures maybe are warming, maybe they're going to approach neutral, but maybe not even that. We'll take a look here in a second. But for the moment, for the past couple of days, past 7 days specifically, temperatures have been warming here and not getting particularly cooler anywhere else. The backed off view, warming temperatures here again off of Ecuador. Cool temperatures, but I mean, this is not horrendously cold. This is, it's La Nina, but it's a pretty weak La Nina, at least right now. Sea surface temperature trend in the Nino 1.2 area. This is the region right there along Ecuador and the Galapagos. Kind of a noisy area, but temperatures, well, today, 547 thousandths of a degree below normal. Just a little bit beyond half a degree below normal. So cool. but not horrendously cold. In the official El Nino monitoring region, the 3.4 area, that area is from south of California out to almost the dateline, temperatures quarter of a degree, 223 thousandths of a degree below normal. So not even officially in La Nina territory. That's a good sign. Got to be half a degree below normal for 5 consecutive months. So, and you see, we were actually above normal in June and July. I mean, not in El Nino territory, but at least it was not wildly negative like it was last fall and winter. We've dropped colder, but not all that cold. Semi-good news. And then just one more chart. Upper ocean heat anomalies. West Pacific here, East Pacific here. Over time, back a year ago, September of last year, warm water in the West Pacific building steadily into February, while cold water in the East Pacific built steadily. November, the peak of our La Nina. This is the hallmark of La Nina, cold water in the East Pacific. Colder than normal water, holding solid into March of this year, and then active phase of the MJO pushed over the West Pacific, took some of this warm water, pushed it off to the east, almost the whole way across the Pacific. That was Kelvin wave number 1. Kelvin wave number 2 in April, May, a third Kelvin wave in June, and then the whole thing. Notice how much warm water was here? Well, those 3 Kelvin waves tapped it dry. It almost went dead neutral. Now we're back in a weekly building warming trend as cool water again starts building. But according to this, the peak of it has already happened. I mean, we're kind of getting that sense from looking at all the other data too, that if this is the worst we have, we're in good shape. I mean, it's not great, but it's not, and typically, so this is the first pulse of La Nina. This would be the second piece, and the second pulse, and typically the second pulse is weaker than the first. We're not going to say that this is the peak of our La Nina yet. Typically it happens in like the October-November time frame, but it gives us at least a little bit of hope. Maybe, I'll just believe anything hoping that we don't get any worse than this, but I'm not going to completely buy into it yet. So what's going on in the atmosphere above the ocean? Okay, we talked about the MJO and sort of trends in it. We've talked about subsurface ocean temperatures, balances of warm and cold water and what they're doing and what that means in terms of El Nino, La Nina, and Kelvin wave potential. We talked about ocean surface temperature, which kind of right now seems kind of neutral. But what's going on in the atmosphere? Okay, Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti in the Pacific, Darwin roughly in the Indian Ocean. When Tahiti has lower than normal pressure, the index goes negative. And we're looking at the daily contribution here, and I don't see hardly any negative values. A lot of high pressure over Tahiti. And again, that speaks to that high pressure bias thing that we were talking about over the date line. Well, this is kind of a symptom of that, okay? Talking to La Nina. But whatever. We'll say daily contribution, it's very noisy. Let's average it out over 30 days, and we can sort of see a trend. Right now, we're at plus 7.6. And if you go back, well, we were up at plus 11. We dipped down to, what is that, 3.11, something like that. And now we've been back on an upward trend. So La Nina kind of faded, and now maybe it's building. Or is this maybe just the MJO playing its game? So then you go out 90 days and go, okay, this is going to really, that'll filter out even the phases of active-inactive phase. We're at plus 8.42. We were down to 4.88 in mid-August, and now we're also heading back up. So sort of indicative of a building La Nina trend. Let's graph it out. Here's the 30-day Southern Oscillation Index graphed out back in January. Negative values, weak El Nino. As we got into 2020, these are the active phases, the upward spikes. The inactive phases, the MJO. They were all stronger than the downward spiking active phases. Inactive phase in control, peak of La Nina in the atmosphere in January 2021. And then big active phase, got us almost to neutral. Another one kept us at neutral. We've recently had a big inactive phase, another active phase. So we're just hovering somewhere above neutral right now. And last year we were already pretty well. We were up to, in the September timeframe, we were already around 10, plus 10. This year we're at plus 6, let's say. So maybe a little bit off the mark. We'll see how we go. Still suggesting a La Nina trend. All right, then finally, the CFS version 2 forecast for the Nino 3.4 sea surface temperature anomalies. Okay, this is in the official El Nino monitoring region. Last year, our temperatures were down about minus 1.35 degrees, something like that. Clearly a La Nina signal, not positive, where we'd want to be if we were in El Nino. We got about to neutral in June. We've been falling since then. The models, this one, the uncorrected version, says we're going down to minus 1.5 degrees, colder than where we were at in this one. But if you remember, probably don't, I barely remember, at one point this model for last year said we were going to be down almost, I think it was 2.25 degrees below normal, and here's what we really ended up with. So this one says down to 1.5 degrees, maybe 0.75 degree would be my guess if we were to eyeball it. So, and then after that, after you get into January, a rapidly rising trend getting us to neutral as we get later into spring, which would be really great. Now this is the raw data. The PDF corrected one, which is NOAA's attempt to sort of say, yeah, we understand there are issues with the raw data, and I think there's some computerized analysis that tries to deal with the biases in the CFS model. This model says temperatures down to 1 degree below normal. Again, last year 1.35. I think even that is overhyped. We'll see where we're at, but the atmospheric component of the model that we're looking at just doesn't suggest or even smell of a horribly strong La Nina pattern this winter. I hope I'm wrong. I hope I'm right. I'm hoping this model is wrong. We'll have to see, but for now, this has been pretty stable, and if anything, it got colder the past week than what we were looking at last week. So more to follow on that. So for right now, there's little swell in the water, and the operative word is little swell. Rideable, southern hemiswell in California. Hawaii already got their little share. The good news is a series of 3 storms. It almost looks like one big interconnected storm, and it kind of is. It's just redevelopment of the same storm as it makes its way across the South Pacific, generating 37 to maybe 40-foot plus seas the whole way across the South Pacific. That certainly should result in some solid swell. Not huge, not even, I won't even say significant class, just again, sort of the theme of this summer is steady, just nonstop, especially for California. Rideable swell, but nothing that ever really gets big or over the top. And at this point, given it being a La Nina summer, you take what you can get and be thankful for it. The other good news is North Pacific, maybe we'll try the model. It's a bit of a reach for the model still. We'll see what happens the next couple of days. But maybe some northwest swell from the Gulf for California north of Point Conception. But again, operative word, pretty small there. Probably not a whole lot for Hawaii. Looking beyond that, the models maybe suggesting La Nina not getting as strong as it was last winter, we're hoping, but then other data suggests, oh yeah, maybe stronger, which seems completely unrealistic. So we'll say the jury's out on that. We're hoping that the center, the core of the high-pressure La Nina focus is actually more out towards the date line. That would allow low-pressure systems to track over it into the Gulf of Alaska and down the Pacific Northwest coast, bringing in some much-needed moisture. We're still thinking that is very much a possibility. We're not saying even normal rainfall for California or the Pacific Northwest this coming winter, but if I were to venture a guess, maybe 75% of normal. No real data to support that. That's just purely eyeballing it, but we'll take any grasp I hope we can get. We need water. All right, if you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, ring the bell, subscribe. If not, go to stormsurf.com. When we post the video, a link to the video will be posted at every page of the top of the site. You can look at it that way. All the data, of course, came from stormsurf.com. You can pick through the site during the week, build your own mental forecast, and then compare and contrast it to whatever we present. If you don't like what we have to say, or you have other ideas, comments are always welcome. I'm not on top of everything. Some of the readers that we have, or viewers that we have, are pretty smart cookies. They present other ideas, and then we all contribute and talk about it, and and then see what happens the week after that and the week after that. So thanks for watching. We enjoy having you here, and we'll do this again next week. Same time, same channel. Have a great weekend.